All right, so welcome to part two. In this part, we're going to talk about what's in the .git directory and how do we actually use that data to build a commit graph. So first things first, let's review how to read files in Python. So first, you got a file, you got the path to the file. You first want to input that path and then use open on it, and it'll output a file object. And then you get the text within the file by reading, like by doing file object dot read, and it'll output like a string with the text. And the input to read is like both the file and the number of bytes, but the default is it'll read the entire file. So you just really just want to do like file.read on any of the files within the .git repo, and it'll give you the string with all the data. And once you're done reading, you want to close the file just to be safe. Okay, so what does it mean by the commit graph? So when we're making commits, there are parent commits and children commits. So like some commits come first, right? And then as you iteratively keep building on previous commits, you'll commit new code, and then there are children of your new commits are children of your old commits. So in this example on the right, you can also have branching and merging, which is what makes this project a little more complicated. So in the example on the right, well, first we just have like an initial commit, and then we keep rolling, and then we eventually get to this one, and then we have two branches. So because we have two branches, there's one parent commit with three children, and they end up at three different branches. So this one commit has like three child commits, and this is part of what we want to track in our graph. Uh, Also, in the example on the right, we have a merge. So like in the example on the left, this was a branch, and here we have a branch and then a merge. So this commit has two children, and also this child commit has two parents. So let's say like we're working on master, we branch off to make a new feature called dev, and then we merge dev back into master to make this child commit, and this child commit will have two parents. So two we basically want to recreate these graphs with the commit like node structure, class structure that it gives in the spec. Okay, so how do we do this? How do we actually read what's in the .git directory? So each object in Git has a hash, and this includes commits. So for instance, let's say we have a commit with the hash 83BAAE whatever. So to read the data for this commit, well, we look in .git slash objects. That's the directory where all the object data is. Excuse me. And the data for an object with this hash 83BAAE, etc., is going to be in .git slash objects slash 83. So it'll take the first two characters of the hash, and that's the directory within objects. And then it'll take the rest of the hash, and that's the file name within that directory. So the path, like how we read the data for a commit with this hash, is 83BAE whatever, is we look in .git slash object slash 83 slash BAE dot 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 dot. Okay, so let's try looking for a commit and like reading the commit data just from the command line. So I know that this file, cd4d ls, I know that the hash 4d75cae, etc., I know that this file is a commit. Like this hash is represents a commit, and it's stored in the file like .git slash object slash 4d slash 75cae whatever. So let me try. So why don't I just try to cat this file? So I'll try catting this file. Okay, it's garbage. I can't read this. It's not in human readable format, and that's because it's compressed and encoded. So how do we actually read this data? Well, on Python, this is where zlib comes in. So we use a zlib to first decompress this text, like we read out the text into a string, we get some garbage like this, then we decompress the compressed text using zlib, and then we decode the already decompressed text into the UTF-8 format, which is just like our normal human readable format. So that's how you read these hash these object files on Python. You use zlib and do this decompress decode business. So the way we do it on the command line is we use git cat file, and then we input the commit hash. So that'll be 4D75. Wait, let me just copy and paste it because I don't remember what the whole thing is. Copy. So we do git cat file, and then we do 4D paste, enter. Oh no. Oh, we have to do -t as well. Wait, no. -t is type. We have to do -p. Okay, there we go. So basically, this is the commit data. So the commit is just called Andromeda. You'll see why later. And the committer is me. The author is me. And look, it shows the tree which points to this, or which this points to, and it also has the parent commit, which is crucial because this is how we're gonna like retrace the graph from just all this data that's in these files. So yeah, we can use git cat file in the command line to like read the hash data, and the way we can do it on Python again is to like look in the specific file like 4D/75CAE, like this file right here, 4D/ this, and then we use zlib to decompress and decode the file. Okay, so now we know how to like get the human readable or like version of the data in a commit object file. So how do we actually like retrace our steps? Like how do we actually know what is the commit data and like where are the branch heads? Like how do I retrace that? How do I recreate like this whole graph like right here? Right? How am I going to make this from just a .git directory? Well, the first thing is we want to look at where the heads of the branches are, because if we have the heads of the branches, if we have the heads of the branches here, and we can like look at this data, then we can just find the parent. And then because if you remember, the parent is in the commit file like data. And if we have this data right here, we can find the parent over and over again and eventually do that to recreate the whole graph. So let me go back to, so how do we make this graph? Well, first we look in .git/ref/heads. Let me just show you what's in there. Clear, and then cd dot cd dot, and then ls slash, so we're in .git right now, so we ls/ref/heads. Oh yeah, I put an extra slash in. Okay, so it has two files. Let me actually cd into that directory. Okay, so what happens when we cat master? So these are the two branches that we have. We have Andromeda and master. And when we cat master, it has the hash for master. So like now that we have like this hash, we can, if we want to start off at master and then retrace our steps, we can go into the object file for this hash. So we can do like git cat file and then use this hash. Oh, I forgot the -p again. Okay, -p. And then it'll show you like all the data for that commit. And it's the message is Milky Way. So again, it tells you the parent commit within this file. All right. So moving on. Where can we find these? Well, we just went over that. So that's like in clear. In .git/ref/heads, it'll have like these three. It'll if we were in this repo, it would have these three branches stored. It would have like branch 1, master, and branch 2, and it would tell you their hashes in this directory right here, /ref/heads. So we look in this directory, get the hashes, and then we can look in like .get/objects to find the data that's in those hashes. So we start off with these like branch heads, and then we kind of work our way backwards. Like these are like the leaf nodes of the graph. They don't have children. And then we work our way backwards to like recreate the whole graph. So we find the parent node. So again, if we look up, if we look in the data of the commit file, it has the hash of the parent. And then we can find the parent node in the text of the commit, and we do this recursively to make the full graph. So for this example, like we can keep finding the parent node until we recreate the whole graph. Okay, so let's actually do this for this repo right here, my repo. So let me go into my favorite whiteboard, and we're gonna, as an example, we're just gonna draw this all out.